Hi guys, I Rakesh Sir. Welcome all of you once again to this platform that is the OM Institute. And yes, we have been, having the GATE and ESE concept booster sessions. Okay, learning different concepts from different subjects. And this we have been taking an important topic. You can consider it in maths or aptitude or anywhere. Actually important for entire engineering. The topic, where many students lag behind, they are confused, and that is why we thought of having mastering in probability. We have had two parts of it, and today is the part number three, conditional probability. Very, very good evening, everyone. Keep on joining the session and quickly update all your friends that the session is now available and live on the channel. Okay, so everybody can join. And in this part number three of probability, we'll talk about conditional probability, what it is and what are the questions based on it that can be expected on the level of GATE and engineering services examination. Let's get moving ahead. This is a regular intro about me. Okay. Also, guys, let me keep you reminded that yes, the Genco exam date has been announced, and with respect to that, the OM Institute brings to you the free online test series for EE branch. Okay, where we'll have two full mock tests. One is just on the Sunday, 23rd June, and one will be on the 7th of July. Okay, just have to scan here for the free registrations. Okay, just open the QR code of QR scanner of your mobile. Okay, and the test will be active at 1 p.m. Okay, this is what the Monday we discussed. The probability, as you know, is all about conquering different variety of question, different logics. Okay, so we had Venn diagram based questions and of course counting based questions. Then in the next session, Wednesday, we took up the dice, the cards, and some other miscellaneous questions where even geometry was involved. Okay, and now today we are here into the conditional probability. Next session you will get it on the Bayes theorem. All right, guys. So I'm starting with something very simple, okay, but just to make you to understand the concept of this conditional probability. Okay, but yeah, to be honest, something very simple to start off with. Yeah. So a fair dice is tossed once. What is the probability of obtaining six? Now you'll be thinking, sir, how simple a question it is. Answer, we know 1/6. Let us understand. A fair dice is tossed and it is tossed once. So what is my sample space? As you know, we represent omega as my sample space, and sample space is what for us, dear? Sample space is the list of all possible outcomes. So when a dice is tossed once, it could result in any of the numbers 1, 2, 3, 4, 5, 6. And because it is a fair dice, all the outcomes would be equiprobable. Okay, there is no biasing here. Now I want the probability of obtaining 6. Okay, I want the probability of obtaining 6. Okay, so let's say A. Let's say A is the event of obtaining 6. Let me define it as event. Let me write down some theory here. Okay, event of obtaining 6 is suppose the event A. Okay, now what is the probability of A? We know favorable by total. We know the very simple idea. The probability of getting 6 is 1 out of 6. Okay, because my favorable event is only 1, I only want 6, and my total outcomes are 6. We know that we also write this as NA by N omega, number of favorable outcomes. Favorable event is A. So how many elements in A? Okay, A is the event of obtaining 6. So if I want to write down the set A, I only want 6. Okay, so in my favorable set, I only want to include 6. So how many elements are here? 1. Divided by 6. What is the 6 total outcomes? Where are the total outcomes? It is written inside sample space. So number of elements in the sample space. So as we know, simple probability is Na by N omega or favorable by total in simple. Favorable by total. Now, what is the probability of obtaining 6 given that an even number has occurred? Okay, so now it looks like a similar question. Again, what is the probability of getting the same number 6, but an additional information that an even number has occurred? There is an additional information. Okay, what is that additional information? Even number has occurred. Let me define this event. Okay, let me define this event. And suppose B is the of event of obtaining what? Obtaining this even number. It is event of obtaining the even number. So if I want to write down the set of B, if I want to write down the set of B, how many elements are there in set B? How many even numbers are possible? 2, 4, 6 within the dice. 2, 4, 6. Now, given that even number has occurred, it is sure that whatever has occurred is out of this 2, 4, 6, and I'm sure that 1, 3, 5 cannot come. I'm sure 1, 3, 5 cannot come. Okay, now what is the probability of getting 6? Okay, now dear, if I want to write down what is the probability of getting 6. Okay, so now still I want only one outcome, one favorable outcome, but I am now confirmed that only 2, 4, 6, any of this outcome has occurred. 1, 3, 5 has not occurred. Sure, somebody has told me. Okay, so I need to search the probability of 6 out of these only, and these are only 3 elements left. These are only 3 elements left. Okay. That means something which is given. Okay. Something which is given. So now whatever you need to search in future is out of this given event only. If 246 given, 135 has not occurred. That means whatever is given here, this now behaves like, okay, new sample space. I can say that this now behaves like new sample space. Whatever has to be found within this only, outside this nothing can occur. Okay, and that is why you see denominator 3. Okay, because we write down favorable by total. Total outcomes are in the sample space, and this time my sample space has 3 outcomes, and favorable is again 1. Favorable is again 1. Right? Favorable is again 1. How do we write down this? How do we write down this? Let's formulate this properly. Of course, a very simple answer, 1 by 3. If I need to formulate this, see, my question was probability of obtaining 6, which I called it as event A. Okay, whose pure probability, there's a difference. When I only calculated probability of A, I got 1 by 6. Probability of obtaining 6. Okay, 1 by 6. But probability of obtaining 6 given with some additional information. A condition is given. Okay, a condition is given. Which condition given? Even number occurred. That is the event B. We write it this notation. Probability of the same in event A, but now given some other event has occurred. Okay, it has changed. It has changed. It has changed. The new answer was 1 by 3. This is what we denote as the symbol of given that. That's what I'm explaining here. Probability of obtaining 6, that is A. Given that, this symbol, slash or vertical, anyways you can draw. Given that even number has occurred, B, we write this next. PA given B. This is the event whose probability is required, and this is the event which is given. Okay, so probability of an event under some given conditions. That is conditional probability. So P of A by B is the probability of event A given that an event B has occurred. And what should be the formula? As I told you now, whatever has been given, whatever has occurred, this becomes your new sample space. So total outcomes are the outcomes of sample space. So now normally probability we write down denominator as n omega. But in conditional probability, my denominator will become number of elements in the new sample space. That is number of elements in the set B. Number of elements in the set B. That is my new sample space. Now, what is there in the numerator? Favorable. Okay. Whose probability is required? A. Okay. So, should I only write NA? No. Okay. Those elements of A which are within the sample space. We don't go outside the sample space. That is why we call it as universal set. My sample space is my universe and I cannot go beyond my universe. Okay. So, maybe it was not in the previous question, but maybe there are some events of A which are outside B. But I'm telling you now, outside B, nothing occurred. Whatever has happened within B. So which events of A to be counted, which are within B, which are common with B, and that is why I use this intersection notation. So we don't write NA here. N of A common with B divided by NB. Okay, and now what is this? We divide both numerator denominator by n omega. So NA intersection B by n omega is the pure probability P of A intersection B. Similarly, NB by n omega is the pure probability of B, that is written as PB. Okay, so we can write down the formula in two ways. Probability A given B is NA intersection B upon NB, or in terms of probability PA intersection B upon PB. Important formula. In the previous question, what you found, okay, P of A given B is 1 by 3, okay, which is not equal to P of A, which is not equal to P of A. That means B occurred and it changed the probability of A. That means somehow A is related to B. If B occurs, there is some change occurring to the probability of A, right? But suppose in a scenario, P of A given B comes out to be P of A. Suppose, let's assume. Okay, we'll see examples then. If P of A given B turns out to be P of A only, that means even though B occurred, it does not change the probability of A. Even though B occurred, it does not change the probability of A. Probability of A. That means A does not depend on B. Okay, that means A does not depend on B. That is what we can conclude. Okay, A does not depend on B, or at least probability of A does not depend on B. At least I can talk in terms of probability, that the probability of A does not change with respect to B. So probability of A does not depend on B. And such cases we call the events and independent events. This is what is the theory behind independent events. Okay, so if two events are independent, if occurrence of one does not change the probability of occurrence of other, P of A by B is equal to P of A. Okay, now let us use the formula. This is one basic condition. So formula is P of A by B is P of A intersection B upon PB. This should be PA. So here we come to the important result. P of A intersection B will be PA into PB. Okay, you can multiply PA, PB directly. P of A intersection B is PA, PB if the events are independent. If the events are independent. If they are not independent, then we use the multiplication rule, something similar only. Okay, like P of, see, if I want to write down what is P of A2 given A1 formula. Okay, now talking in terms of events A1, A2, A3 rather than ABC. What is P of A2 given A1 formula? It is P of A2 intersection A1 divided by what comes in the denominator, the probability of given event, and given is suppose A1. Acha. P of A2 intersection A1 or P of A1 intersection A2 is same. Na? A1 intersection A2 or A2 intersection A1 is same in the set. So that is why what is P of A1 intersection A2? I can write it as P of A1 into P of A2 given. How do you understand this? Probability of intersection of two events. Probability of intersection of two events. P of A1 intersection A2 will be equal to probability of A1, first event, into probability of A2, that is second, given first has occurred. Given first has occurred. Probability of first into probability of second given first has occurred. Clear, everybody? Similarly, A1 intersection A2 intersection A3. Okay. Will be equal to probability of A1, probability of first. Then into probability of second, given that first has occurred. Given that first has occurred. We assume first occurred and then write down the probability of second. Into probability of third, given first and second both occurred, A1 intersection A2, A1 and A2. So if first and second both occurred, then what is the probability of P3? The sequential chain. This is what multiplication rule. We'll have questions, then to elaborate more. Okay, probability of first, simple. Probability of second, given first occurred. Probability of third, given first and second both occurred. These are the multiplication rules. Okay. But again, I'm telling you, the questions that normally turn up, okay, so just basically, to be very honest, basically one formula, that is the conditional probability formula, P of A2 given A1, or whether you remember in the form of P of A given B, that is important. Questions again will more test your logic and, ability to read a particular data, read a particular given situation, rather than, testing your different formulas. No. So let's understand different variety of questions. Some questions can be straightforward from conditional probability. Yes, simple one marker type question. P of x given, P of y given, P of x intersection y given. What is the value of P y by x? Sometimes, yes, you indeed get 1 mark. Very simple question from this. Okay, so what is this P of y by x? Okay, it is simply P of y intersection x divided by P of what? P of given event. Given is x. Okay, now y intersection x or x intersection y is same. So 1 by 12. Probability of x given is 1 by 4. Okay, 4 goes above. So it is 4 by 12 or 1 by 3 is my answer. 1 by 3 is my answer. That's it. Option number C. So yes, sometimes you get very simple. Sometimes again simple question, but in form of language. Okay, this is also simple. Next variety of questions, we'll see where some counting and all will also be involved. Have a look into it. An examination consists of two papers, paper 1 and paper 2. Okay. Probability of failing in paper 1 is 0.3 and that in paper 2 is 0.2. Okay. Given that a student has failed in paper 2, some event is given. Okay. But initially we are talking about probability of failing in paper 1 and paper 2. Okay. So let me define it as event A. Event of failing in paper 1. Okay. And similarly, let us say B is another event of failing in paper 2, right? Failing in paper 1 and failing in paper 2. Now, what is the probability of A? Probability of failing in paper 1, 0.3. What is the probability of B? Probability of failing in paper 2 is 0.2. Okay. Now, given that a student has failed in paper 2, now see which event is given. Given that a student has failed in paper 2, that is given the event B. Given that a student has failed in paper 2, probability of failing in paper 1, that is event A, is 0.6. What is the probability of student failing in both the papers? Acha, failing in both the papers means failing in paper 1 and paper 2, and means intersection. So this is about A intersection B. Okay, so the question is asking you what is the probability of A intersection B? What is the probability of A intersection V? A intersection B. Okay, that is what is the question. Probability A intersection B. That's it. Chalo. Let's figure out now what is the probability of student failing in both the papers. So we can solve it by this conditional probability formula only, na? They have given P of A given B, and we know that the formula is P of A intersection B upon PB. Okay, and this is given as 0.6. Okay, so here you get your answer straightforward. P of A intersection B is 0.6 into PB. What is PB? PB is 0.2, and hence answer 0.12. Answer here is 0.12, option number C. So this is again simple formula based, but the events are given in words. You can write it as A and B or A1, A2, any events you can name and write down the basic conditional probability formula. Okay, let's take another step. Now, something based on dice. Two fair dice are rolled and the sum R of the numbers that turn up is considered. Okay, what is the probability? Okay, so just let me quickly recall. Okay, something we discussed in the last session. Okay, we can use that because I told you in the last session. Okay, dice being tossed twice or some of the outcomes of two dice is a very common data in questions. Directly, indirectly, questions come up on this. Okay, so how many cases are there? Okay, let us recall this from our last class discussion. Okay, how many elements are there corresponding to sum equal to R? Okay, corresponding to sum equal to R. Okay, for any value of sum less than equal to 7, we got the result as R minus 1. And for any value of sum greater than 7, the result was 13 minus R. Okay, the result was 13 minus R. This is something we have discussed in the last session. You can watch that if you have by chance missed it. Okay, two fair dice are rolled and the sum R of the numbers turned up is considered. Find probability R equal to 8 given R by 4 is an integer. R equal to 8 given R by 4 is an integer. Given R by 4 is an integer. Okay, let's have a look into it. Given that R by 4 is an integer. Okay, have a look into it. Chalo. Now, let me call this as probability of A given B. Probability of A given B. Okay, so, chalo. So we have probability R equal to 8 given R by 4 is an integer. Acha, R by 4 is an integer. R by 4 is an integer if R is equal to what? If R is equal to what? R by 4 is an integer means R is divisible by 4. Then only the result is integer. So R can be how much? 4 or 8 or 12. Acha. If the sum is R, what are the possible values of this R? We know that the sum can take any value. Minimum value of sum of two dice, 1 plus 1. Minimum is 1 plus 1. Maximum is 6 plus 6, 12. So there can be any value 2, 3, 4, etc. up to 12. Okay, so that is why what are the numbers which are divisible by 4? 4, 8 and 12. Okay, from 2 to 12, these are the three numbers. So R by 4 is an integer means R is equal to 4, 8, 12. Now apply P of A given B formula. P of A given B formula, this should be equal to P of A intersection B. Numerator, we write down the intersection divided by probability of B. Probability of R equal to 4, 8, 12. Okay, now what is the intersection in the numerator? What is the intersection in the numerator, dear? What is the intersection in the numerator? 8, 4, 8, 12. The common is 8. The common is 8. The common is 8. Only intersection. Divided by denominator will contain all three. 4 and 8 and 12. 4 and 8 and 12. 4 and 8 and 12. Chalo. 4, 8, 12. Done? Okay. Now let's see. Let's see. Okay. What is the probability R equal to 8? Or let me write down R equal to 4, 8, 12. Na? Okay. Let me call it as, let me write down R may be equal to 4 or 8. So let me split this probability. Or 8 or 12. Denominator contains, okay, the probability of these three outcomes because it is or case we have added it. Now, what is the probability R equal to 8? 8 is greater than 7. So 13 minus 8. Okay, that is 5. Okay, 13 minus 8 divided by, see, this is only number of elements. What is probability? Okay, probability will be NA, okay, number of elements divided by number of elements in sample space. Okay, number of elements in sample space, 2 dice. It is a case of 2 dice. So number of elements in the sample space will be 36 here. Okay, will be 36 here. Okay, But this 36 will come in everything, so it will be cancelled out actually. So probability R equal to 4. 4 means, okay, 4 minus 1. Okay, 8, again 13 minus 8, and 12, 13 minus 12. So see, 36 is actually, you can eliminate also, no need to write, it is cancelled. So it is 5 divided by 3 plus 5 plus 1, that is 9. Okay, 5 by 9 is my answer. Conditional probability question involving some counting. Okay, formula is again simple, P of A intersection B by PB, but it is all about, getting that logic of dice, which we also discussed in the previous session. Okay, chalo. Done. Let's move ahead to the next. Let us then move ahead to the next question. Okay, again based on dice. A die is thrown 3 times. Okay, and the sum of the numbers is going to be 16. Okay, now it is thrown 3 times. A die has been thrown 3 times, and the sum of the numbers is found to be 16. Okay, on 3 dice, what is the probability that 5 appears on the third throw? 5 appears on the third throw. Okay, so we want 5 appears on the third throw. Suppose this is event A. I want the probability of event A. Sum of the numbers is 16. Suppose this is event B. Okay, so what I want? I want probability A given B. Okay, probability A given B. Oh, and it is equal to probability of A intersection B upon PB upon PP. Okay, or it is also equal to, we can put it this way also, N of A intersection B upon NB. As I told you, either PA intersection B upon PB or N of A intersection B upon NB. Correct? This is what it is. Now, okay, sum of the numbers is found to be 16. Okay, how many elements are there in B? Okay, sum B corresponds to the case that sum is 16. Sum on the 3 dice. Okay, dice thrown 3 times. Okay, so sum on 3. It is found to be 16. Okay, it is found to be 16. Can you do it without a 6? See, it is simple only. Can you do it without a 6? If you don't have a maximum sum is 5, 5, 5, 15. 5, 5, 5, 15. Okay, so you cannot do it without a 6. Okay, the 16, if you want the sum is 16, at least one 6 is required. Okay, if there is one 6, then the remaining sum is 10. So it can be obtained as 5, 5. Okay, or 6, 4, or 4, 6. Tell me if anything else is possible. Because without 6, it is not possible. Okay, so if you take 1, 6, 2, 5, or if you take 2, 6, 12 plus 4, 16. Okay, okay. And even the 2, 6, the 4 can be third, second, and even first. Okay. Now here also arrangement I will tell you. So better, let me only put this way. Okay. So either 1, 6 and 2, 5, or either 2 6s and 1, 4. Okay. But this 1, 6 can be in 3 different positions. So here also 3 cases will be there. This 1, 6 here can be in 3 different positions, first, second, third. Here think about 4. This 4 can be in any position now, first, second, third. So this will also have 3 cases. Okay. So how many total elements in B? How many total elements in B? Okay, it will be 6 actually. How many total elements are there in B? It is actually 6. Okay, now we have to think about A intersection B. Okay, NB is okay, 6. A intersection B. A intersection B. What will be A intersection B? Okay, that 5 appears on the third throw. Okay, A intersection B means A means 5 on third toss. Okay, this is A. Intersection means B means sum is 16. Okay, that means dash dash and 5 has to be fixed on the third toss and sum is still to be 16. Okay, sum is still to be 16. Okay, so that is only possible if you take 6 5 here. Okay, or 5 6 here. Okay, or 5 6 here. These are the possibility, because if 5 is fixed on the third toss, so remaining 2 tosses should sum to 11, and 11 means 6 5 or 5 6. So how many cases here? How many cases here? Here you have 2 cases. Okay, so the answer is 2 by 6 or 1 by 3. What you learn here is the question is again mostly on counting. It is more on counting. The formula is very simple. P of A intersection B is N intersection P of A given B is N A intersection B upon NB. But mostly, whether you're able to understand the question, read the question, whether you're able to make the cases sum equal to 16 for 3 dice, or previous one was 2 dice, and etc. Last session, I have also taken a question where sum of 4 dice were considered. Okay, so all such patterns. Dice, anyways, I told you is really an important topic. Dice really is an important topic, anyways, all the time. Okay. All right. Next question. An unbalanced dice with six faces numbered from 1 to 6 is thrown and it is unbalanced. Okay, so another question on dice. Okay, the probability that the face value is odd is 90% of the probability that face value is even. Okay, the probability of getting any even numbered face is same. The probability of getting any even numbered face is the same. What does this mean? That the probability of getting 2 or probability of getting 4 or probability of getting 6, this is the same. Clear? This is going to be the same. Okay, the probability that face value is odd is 90% of the probability that face value is even. Okay, probability of getting odd face, okay, is 90%. That is 0.9 of the probability of getting even face. This is one case. Okay, let me call it as PO. That is 0.9 PE. But also, dear, when you toss a dice, the outcome will be either even or odd. There is no number which is neither even nor odd. Okay, whether you get 135, you get odd, or you get 246, you get even. There is no other possibility. So either you get even or you get odd. Okay, so what is the probability of odd plus probability of even? This becomes the probability of all possible outcomes. When you combine odd and even, you get all possible outcomes, and probability of all possible outcomes is 1. Okay, is 1. Okay, so here let me put down the value of P naught, that is 0.9 PE. Okay, plus PE is 1. So 1.9 PE is 1. What is the value of PE? Is 1 upon 1.9. See, I'm not reading the further question, but whatever can be extracted up to this, I'm doing. Okay, probability of E. Okay, now what should be probability of getting any even numbered face? So how many even numbers are there in the dice? It is 2, 4, 6. So when I say PE, that means probability of getting any even number. That means probability of getting 2 or 4 or 6. Okay, that means probability of 2 plus probability of 4 plus probability of 6. Okay, that is PE. Okay, and that is 1 upon 1.9. But probability of 2 or 4 or 6 is same. That means this is also equal to 3 times probability of 2. Let us convert everything in probability of 2. That means PE, which is 3P2, which is equal to 1 upon 1.9. So what is P2? 1 upon 3 multiplied here, 5.7. This is also equal to P4 or P6. Probability of 2 or 4 or 6 is same. That is 1 upon 5.7. Okay, if the probability that the face is even, given that it is greater than 3, probability that the face is even, given that it is greater, now comes the conditional probability. Probability that the face is even, probability that the face is even, given that it is greater than 3 is 0.75. Okay, now let us write it here. The probability that the face value is even, given that it is greater than how much? Given that it is greater than 3, okay, is 0.75. 0.75. Which one of the following is the closest to the probability that face value exceeds 3? Exceeds 3 means greater than 3. Okay, again, dear, let us call it as some event A. Let us call it as some event B. Okay, probability of A given B, okay, is probability of A intersection B upon P of B. Okay, what is the intersection now? The number is even as well as greater than 3. The number is even as well as greater than 3. Greater than 3 and even, so 4 or 6. Okay, and denominator is PB, probability greater than 3. Okay, and this is 0.75. Okay, but what is P of 4 or P of 6? That is P4 plus P6. If I add both, okay, upon PB. Okay, and this is 0.75. So, dear, what is the PB? What is the PB? Okay, P4 plus P6. Okay, P4 plus P6. Both are 1.1 upon 5.7. So I multiply by 2 directly. Divided by 0.75. This is PB. And what is PB? Probability of B. B means a number greater than 3. And that is what is the question. What is the probability of getting a number which is greater than 3? What is the probability that the face value exceeds 3? Or that means greater than 3. Okay, so we just have to complete this calculation and write down the answer. Okay, so let me do up the calculation. You can also keep doing parallelly. Okay, further divided by 0.75 and 0.4678. Okay, 0.4678. So option number B then. This is turning out to be 0.4678. Closest one is 0.468. 0.468. This is the closest option that can be matched. Okay, dear. See, again, conditional probability came at the last. That is the formula that you should know. But rest, it was all about, okay, decoding this coin. Okay, decoding this dice. This unbalanced dice. Okay, probability of getting 2, 4, 6 is same, but probability of getting odd number is not same as that of even number. So some biasing is there. Okay, some biasing is there. Okay, dear. That is what this question speaks about. All right. Let's go to the next question, dear, then. Okay. This is again a good question because again it is language based. Okay. So that language word by word we have to decode. P and Q are considering to apply for a job. Okay. The probability that P applies for the job is 1 by 4. Probability that P applies for the job given that Q applies. So देखो, P and Q are applying for job. Okay. P applies for the job has some probability. Q applies for the job has some probability. So again, better let me define event. Okay. Let A be the event, okay, that P applies. Let A be the event that P applies for the job. Okay. And let B be the event that Q applies for the job. Okay. Like, some earlier question, failing in paper one, failing in paper two, I have written it form of A. Similarly, I'm doing here. P applies for the job is event A. Q applies for the job is event B. Okay. Now, probability that P applies for the job. First statement. Okay. Probability that P applies for the job. Okay. Let us say this is my first statement. So what is that first statement? I'll write the data here separately. Probability that P applies for the job means probability of event A, 1 by 4. Now, next statement, probability that P applies for the job given that Q applies for the job. Okay, let us say this is statement number 2, language number 2. Okay, I'll write it here separately. Probability that P applies for the job. Okay, P applies means say, given that slash, given that what Q applies. Given what Q applies. Q applies means B. So given the event B, probability of A is how much? 1 by 2. Okay, next probability that Q applies for the job given that P applies, reverse. Okay, suppose this is number third. Okay, so what is my number third? I will write it here. Probability that Q applies, dear. Probability Q applies is event B. So you are given the probability of B. Given that P applies, given that A, and this is how much? 1 by 3. This is the 3 data given. Okay, now find the probability that, okay, probability that P does not apply for the job given that Q does not apply for the job. Okay, suppose this is my fourth statement. The fourth statement is your question. What is the probability that P does not apply for the job? P does not apply for the job means event A does not occur. Okay, so if the event does not occur, we call it as A complement, right? We call it as A complement. Okay, given that Q does not apply for the job. Okay, given that Q does not apply for the job. Q does not apply for the job. That means event B do not occur. And this is not the given data. This is what is my question actually. This is what I need to find. My fourth statement. P of AC given BC. Okay. Chalo. Let me start with the question first actually. Okay. I need to solve P of AC given BC. Conditional probability formula will be applied and that is known as AC intersection BC and divided by P of BC. Okay, what is the probability B does not occur? Probability of B complement is always 1 minus PB. Probability of A complement is 1 minus PA. Okay, now here we can use the De Morgan's law, P of AC intersection BC. Okay, this can be, okay, related with De Morgan's law. Okay, okay, none of them occurs. Okay, like in the part 1 session I've told you. Okay, A does not occur and B does not occur. Probability of none, okay, is 1, or we can use it like this also. Probability of A complement intersection B complement. Understand? A also does not occur, B also does not occur. Intersection means and. So which event occurs? None of the event occurs, and that is equal to 1 minus probability of at least 1. There is one important result I told you in the part number 1. Each and every fundamentals that we have studied are important. Okay, 1 minus P of A at least, 1 minus probability of at least one of the events occurring, and at least one of them is A union B. And that is what is De Morgan's law also. That is what is De Morgan's law also. What is that De Morgan's law? A union B actually whole complement is given by A complement intersection B complement. Okay, so that when I want to write down probability of A complement intersection B complement is equal to probability of A union B whole complement. Okay, like what is probability of B complement? 1 minus PB. Similarly, this is 1 minus P of A intersection B. Okay, or we can solve from 1 minus probability at least. At least one of the event occurs is known as the union of the event A and B. Okay, so I want 1 minus P of A union B upon 1 minus PB. Now this is further equal to how much? 1 minus P of A union B. That is not given. Okay, but that can be written as PA plus PB minus P of A intersection B divided by 1 minus PB. So what I want PA, I want PB, I want PA intersection B. PA is given to me. PA is given to me, okay. But P of A intersection B and PB, this is what something we need to put effort. Let us put the effort from the given data. Okay, let me pick up the data once again. Okay, now first data, P of A, 1 by 4. P of A, 1 by 4. Second data, P of A given B. P of A given B. Actually, let me use a third data because P of B by A is P of B intersection A upon PA. So upon PA, okay, PA is given to me. So I first use the third data, P of B given A. Dear, what is the P of B given A? The P of B given A is known as the P of B intersection A, right? Divided by P of A. Acha, what is this value given? 1 by 3. This is given as 1 by 3. So here we obtain something P of B intersection A or A intersection B, one and the same thing. 1 by 3 into PA, and PA is 1 by 4. So this answer is known as 1 by 12. Okay. Now we can go to the second data. Now we can go to the second data, which talks about P of A given B, and that is, I think, half. Correct. P of A given B is now P of A intersection B, which is known to us now, divided by PB. So PB can be calculated now. What is the value of PB? P of A intersection B, 1 by 12 upon 1 by 2. So this is 1 by 6. I will come back here, put down the data. 1 minus PA. PA is 1 by 4. PB is obtained as 1 by 6. A intersection B is 1 by 12 upon 1 minus PB, and PB is 1 by 6. Okay, so let me multiply throughout by 12. It becomes simple. So it will be 12 minus 3 minus 2 minus plus 1. Okay, divided by, okay, 12 minus 2. Okay, so how much it is? On the simplified note, this is 9, 7 plus 1, 8 divided by 10, or 4 by 5 should be the answer to the question. 4 by 5 can be the answer to the question. Yes, option number A, here it is. Hope you have got this. Is a good question. Okay, and that's what probability is a topic where definitely you can expect some good questions. There can be some simple one fundamentals also, basic counting and basic formula based, but there can be some good questions as well, isn't it? Yes. Okay. So hope you have understood this question as well. Any doubts, please do let me know. Okay. So yes, guys, like every other class, I'll share you the PDF of today's class as well. Okay, and that PDF is going to be password protected. As I've told you, all the PDFs you get in Telegram, whatever I discussed today, all question, solution, everything in detail with the formulas, everything, you get it as a complete PDF, but that is formula protected. Okay, password protected, because if you're watching, if you're honest in putting the efforts, then you get the PDF. That is a simple idea. Let's keep a simple password for today. Based on conditional probability, the password is condition. Everything in small. Please note everything in small. I'll share you the PDF in the same regular Telegram group. Password is condition. CONDITION. Everything in small. All right. Again, guys, let me keep you reminded that yes, the Genco free online test series, okay, has been announced by Ohm Institute for all EE aspirants. You will get two full mock tests here. One is just on this Sunday, coming Sunday, 23rd June. One will be on the 7th July. And you can just scan here. Okay, open the QR scanner on mobile phone and scan here for the free registration. Okay, guys, the offline regular batch for GATE 25 ECEE, the next batch starts June 26th. Okay, that is the coming Wednesday. Okay, the fee 66,000 is currently priced at 56,000, and there are special discounts also, like 50% for IIT and IT students, 50% for any OM pre-old student, and 30% if you're any other state government or triple IT college student. Okay, Now, these are the pure offline batch under the complete supervision of the faculty. You study offline, live at our Hyderabad center. But in case if you cannot travel to Hyderabad by any chance and you want to study online, sitting at your home at your comfort, so online live batch is also available at our platform. Okay, that is at the Home Live app or also our website. You can watch it from the website or you can watch it from the mobile app also. Okay, the website will be homeinstitute.live for this. Okay, so fees 29,999 for Gate 25 is currently priced at 19,999, and similarly for Gate 26 it is currently 28,999 with 24 months of validity, available for both EC and EE. Okay, and here also you get the complete course covered by the same faculty, exact same faculty. Okay, so there is no difference in the content you get in offline and online. Okay, so this also will be scheduled like, you get a complete schedule because I told you it is a live batch. So it comes up with a schedule. It happens at fixed time every day. Okay, by the same set of faculty. If you cannot still dedicate time on a fixed basis, okay, so, you can also have the access to our recorded lectures. Okay, you can visit our website for more updates about that as well. Okay, that's it from my side. Bye bye. Thank you. Next part will be on base theorem. Hope you enjoyed it. And if you learned something about conditional probability, if you enjoyed, put your attendance. Yes. Do not forget to hit the like button and wait for the next session. That is very important base theorem. Actually, very important. And we'll make it very simple by a method known as the tree method. Okay. Bye bye. Thank you. Stay safe and do take care of yourself.